Hello and welcome to CENOS wireless charging tutorial video about LTspice integration. Now, with the latest release of version 1.2, we have actually included the possibility to couple the 3D simulation with an LTspice circuit simulator. And in this video, we are going to take a look at how to do this. Now, here I have prepared two files. First is CENOS case file, which I have already opened in the background, and the other one is LTspice circuit simulation file. Now, if we open this, then we can very nicely see the schematic that has been prepared. We can see that here on the left is the transmitter side, and on the right is the receiver side. And the transmitter-receiver coils are respectively L2 and L4 are the transmitter coils, and L5 and L7 are receiver coils. Now, when you prepare LTspice file for integration with CENOS, there are a couple of things to keep in mind. Now, first of all is within the file, voltage source with a sinusoidal waveform needs to be defined. Now, if by default you are going to add voltage component and it will look like this, then if you right click on it, you can simply input the DC value of the voltage. Now, instead, what we need to do is we need to open the advanced settings, change the voltage source to a sine wave, specify DC offset, and define the amplitude of voltage, which in this case would be 424 volts. Also, here, the same value. And we click OK, and we get the voltage definition as it is needed for the LTspice file to be able to import within CENOS. Now, this is a must actually. If you have a DC source within your LTspice simulation defined, and for example you have an inverter schematic, simply replace it with a voltage source, because this is currently the only source type that is working with us. Now, the other things to keep in mind are actually two. So first of all, for coils, it is I would suggest to define the coil self-inductance already right now. Now, the whole point of the integration between the LTspice and CENOS is actually to calculate iteratively these values, such as coupling coefficients and also self-inductances of the coils. But I would really suggest to at least input some kind of estimation of what it could be, because that will help CENOS with the calculation convergence, and it will simply speed up the calculation. Now, you can of course skip this step, in which case if you have not defined self-inductance for your coils, then CENOS will simply predefine some default values and use those as the starting values. But then of course the convergence will be potentially slower and the calculation time could also be larger. Now, in the same way, I would also suggest to define coupling coefficients between every two coils. Now, again, here I have very arbitrarily defined perfect coupling between every two coils. You can, of course, change the values, and you can choose not to define them at all, in which case CENOS will predefine them. But again, if you manage to define coupling coefficients between coils more accurately already at the beginning, then the calculation, the convergence will simply take less time. Now, to export this kind of a schematic and import it within CENOS, we need to convert this into a netlist file. Now, there are a lot of different file types available within LTspice, but the one that we need is the original one, which can be kind of shown if we click on View and click here on Spice Netlist. Now, this shows us actually a netlist file format that needs to be imported within CENOS. And actually, it not only shows it, but it also generates it in the background. Now, if I open the original folder, then here you can see I have a new file, which is called a netlist file of the original LTspice file that I have opened here. So honestly, I don't really need to copy this text, for example, to generate my own netlist file, which I can do. But what I can do instead is I can simply use the newly generated LTspice circuit schematic netlist file. Now, do remember that this is a temporary generated file. So if you now decide to close the LTspice software, then the netlist file will disappear as well. So either save it or simply import it while it's still open. Now, the import on CENOS side is actually pretty straightforward. What we need to do is we need to go into the physics. We need to define the frequency. We need to define all the general system parameters. We need to define ferrites, conductors, or whatever else you have within your system. And if we talk about coils, you still need to define the geometrical properties of the coils. But do notice that I have not defined any kind of applied current or voltage. Why? Because that will be taken care of by the LTspice file. Now, to import it, we need to enable LTspice integration, click on Choose, and simply select the netlist file that we have generated. And I will simply click Open, and that's it. Now here, the last thing we need to do is we need to couple actually the 3D coils with the coils that we have defined within CENOS, within LTspice. Now the difference is if we go into the LTspice, then we see that the coils are called L2, L5, L4, L7. Within CENOS, they are transmitter coil 1, 2, and receiver coil 1 and 2. So we do need to couple the identities of these coils. And how to do this is you can simply go into the coil domain. And here, first of all, you will see that there is no longer an option to apply any kind of voltage or current, because that value will be taken from the LTspice file. And now actually a new inductor ID input field will be presented. And here we actually need to define which coil this is from the LTspice file. Now to do this, I personally like to simply put these one next to another, and we can very nicely see that, okay, so this is my transmitter assembly. All right, so here I will go and define this as L2 coil, meaning that the one against it is L5. All right, then let's go back. The other transmitter coil is L4. And the last one is the receiver coil L7. All right, and that's about it. Now at this point, the calculation, the meshing, and the result evaluation goes in the exact same way as it would go without the LTspice circuit simulation. The only difference is that in this case, CENOS now will exchange information between CENOS and LTspice to update and iteratively calculate things like coupling coefficients and self-inductances of the coils. Now, from the results, the only difference you will see is actually within the CSV file, which if we open, will look like this. Now, originally, without any kind of LTspice integration, this is the information that you will get. But if you enable LTspice integration, then you will also see values calculated by the LTspice. For example, here we can see the actual current and voltage values for each of the coils, and if we scroll down, we can actually also see values that you would otherwise get directly from LTspice, such as voltage drops, but here you can actually get them in a tabulatory format for each of the components that you have included within your schematic. And that's about it. So this was a video about how to integrate LTspice together with CENOS. As always, if you have any questions, please feel free to reach out to our support. But yes, in any other case, have a nice day, and then till the next time.